Alright, we're going to try one more with the board here. I'd love feedback. I'm not going to go more than our current moles unit just because I want to hear what you guys say about what you can see. We're making the most out of my whiteboard here, but we're on assignment 5. We did empirical formula, now we just have molecular formula left. So we know molecular formula is oftentimes how it looks in the real world, and it's many times more complex than the empirical formula, but it can be the same. And how this really works, guys, I mean, I just made up this little mystery formula, but let's just say something is XY2. That's its empirical formula. If we know that this weighs 11 grams per mole, and I tell you, hey, the real thing in the world weighs 44 grams per mole, that would mean we have to take this times 4 to get the molecular formula, since it's 4 times as heavy. If I told you the real thing weighs 88, we would have to take this times 8, because it's 8 times as heavy. And what we do is we just take the subscripts and we take it times 4 or times 8. So number 1 up here says we're given that the empirical formula of a substance is C2OH4. So something pretty complex here, a hydrocarbon. And it tells us the true substance on Earth has a molar mass of 88 grams per mole, and what we want to know is the molecular formula. So my shortcut over the years has kind of just become the MFMM divided by the EFMM. And what those stand for is the molecular formula molar mass and the empirical formula molar mass. This should always come out to some whole number integer. It's either the same exact thing or it's twice as heavy, 3 times as heavy, but it should always be a whole number. So if we go plug in here, we know that the true thing on Earth weighs 88 grams per mole. Now EFMM means we have to go find the molar mass of the empirical formula. So if I really quickly, and again, you'd want to show work here, but if I take 2 carbons and 1 oxygen and 4 hydrogens, that's 2 times 12 is 24, plus oxygen is 16, plus 4 more, that comes out to 44 grams per mole. Now that's nice and easy because we can see that the molecular formula is twice as heavy as our empirical formula. So if I know that it's twice as heavy and the normal formula is C2OH4, what do I have to do with that formula to get the molecular formula? Well, since it's twice as heavy, I got to take that and I have to have twice as many. So C2 becomes C4, O1 becomes O2, and H4 doubled because it's twice as heavy becomes H8. There's my molecular formula. We just got to double check ourselves. This right here is in a 2 to 1 to 4 ratio. 4 to 2 to 8 would be that exact same ratio as my empirical formula, but it's in a much more, a heavier state, if you will. In this case, it's twice as heavy. MF divided by EF should always give you a whole number. They get tougher, but what you want to do on the one on the bottom, I think it's number 6 or number 7, it doesn't tell you the empirical formula. So just like your last assignment, you have to go find the empirical formula first, and you do that by going to grams, getting to moles, and simplifying, and then you can go do your work with molecular formula. These are pretty easy for the most part as long as you keep straight what you're looking for.